In this lecture, we are going to learn about NoSQL database. So the first thing first, NoSQL stands for not only SQL, which means in NoSQL databases, we are not going to use structured query language. NoSQL database is a non-relational database management system which is very much different from relational database management system. So the next big question is, why do we need NoSQL database when we are already having powerful relational database management systems like Oracle, DB2, MySQL and others? So the answer is, with the increase in internet, companies like Google, Amazon, Yahoo, eBay, they started getting huge amount of data with the growing internet traffic and activities over the social media and other websites, which has given birth to a new data called big data, which is unstructured, sometimes semi-structured and also unpredictable in nature. Few examples of getting these kind of data are Facebook, Google, Blog, Twitter, YouTube. So these are the basic sources of getting this kind of unstructured, unpredictable and huge amount of data. What we are getting from these sources are unpredictable in nature and unstructured and also in huge amount on a daily basis. So all we know that RDBMS is designed to handle structured data, and that too they can handle data up to some limit. And these data are, first thing, they are unstructured, second thing, they are coming in a huge amount. So RDBMS failed to handle these kind of data, which is big data, and this inability of RDBMS to handle this kind of unstructured and huge amount of data has given birth to a new database management system, which is known as NoSQL database management system. Some features of NoSQL databases are like they are designed to handle large volumes of structured, semi-structured and unstructured data. They provide high performance, high scalability and high availability. We discuss all these features in detail when we discuss about MongoDB in the next lecture. They provide quick iteration, they support object-oriented programming, which makes them easy to use and flexible in nature. They support dynamic schema, they support auto-sorting and replication, which make them easy to scale out and easy to maintain and easy to be fail-proof. We discuss all these features in detail in the next lecture when we talk about NoSQL database, that is MongoDB. There are four types of NoSQL databases are available right now. The first one is key value stores, which is Redis, Dynamo and React. In this kind of database, we store data in the form of key value pair. So with the reference of key, we store value, and that value can be anything like number or string or character or a document or anything. We can store anything in the value with the reference of a key. The next is column oriented databases. In these kind of database, we store data in the columnar fashion. So first we store data in the columns with the reference of a row ID. Examples are Bigtable, Cassandra and SimpleDB. Graph oriented databases are the next. In this we store data in the graphical manner. Examples are OrientDB, Neo4j and Titan. The next is very popular document oriented databases, and examples are MongoDB and CouchDB. In this course, we are going to learn about document-oriented database, that is MongoDB. So in this kind of database, we store data in the form of documents, and in case of MongoDB, we store data in the form of JSON documents, which are objects. In this lecture, we are going to discuss about MongoDB. MongoDB is a cross-platform, open-source, document-oriented database that provides high performance, high availability, automatic and easy scalability. So when I'm saying MongoDB is a cross-platform open source, it means MongoDB can be used by anyone on any platform. MongoDB uses document to store data, and so it is known as document-oriented database. And since it uses documents, it is easy to access data with the document-based search, which leads to high performance. MongoDB replicates data automatically over different nodes in a clustered environment, which gives high availability of data even if some of the nodes are going down. So replication is a process of synchronizing data over the clustered environment. So MongoDB does it automatically. So whenever some one or two nodes are going down also, we'll be still getting
same synchronized updated data from the active nodes. MongoDB provides auto-sorting with which many machines can be added without doing much configuration or changes, which leads to horizontal scalability. MongoDB provides horizontal scalability, which means horizontally we can scale out our systems, our applications without worrying much about the server configuration. MongoDB does it automatically. We just need to add required boxes to the existing system, and rest of the thing MongoDB will be taking care. And this is the one of the best functionality in MongoDB. MongoDB is a document database. A record in MongoDB is a document which is a data structure composed of field and value pairs. We will be understanding this with this example. See, this is the format of a document in MongoDB. We store document in opening and closing braces. So here course is field and value is introduction to NoSQL database. We are storing field and value. So field will correspond to the value. So if you want to get the value for a particular field, we just need to provide the field ID or field name. And see, with the category colon in a bracket development comma database. So we are giving two values for category field, which is an array. So in MongoDB document we can store array, we can store documents, we can store integer, we can store character, we can store string, we can store images, we can store anything in the field. We can relate MongoDB with relational database. Like in relational databases we use tables, and in MongoDB we use collections. In relational databases we use rows to store data. In MongoDB we store data in documents. Advantages of using documents: like documents correspond to native data types in many programming languages. MongoDB uses JSON documents to store data, which is an object. So it is very easy to use this object in a programming languages such as Java and PHP. Embedded documents and arrays reduce need of expensive joins. Since we are using embedded documents and arrays inside a document, it is very easy to get required result. Like in RDBMS, we store data in the different tables, and when we need some result or some data, we need to perform complex joins with those tables. But in MongoDB, since we are using embedded documents and arrays, it is very easy to get those results. Ability to perform dynamic queries on document using document based query language. This is another good thing about MongoDB, that we can search with the document. We can use document based query language, which is as powerful as structured query languages. Conversion of object to database objects is not needed, since we are using document and documents are like objects. High performance, because MongoDB uses internal memory to store working set for quick data access.
Now that we are having basic overview of NoSQL databases and MongoDB, we are good to look at difference between RDBMS and MongoDB. So we can understand from this picture that RDBMS will have database server, and then on the database servers we will be having our databases running, and in databases we will be having our tables, and tables will be containing rows, and every table in relational database management system will be having fixed schema. So first we decide on the schema. Schema means first we decide how many columns that table is going to have and what kind of data we are going to store in the table. So first we decide on the table structure, that is schema, and then we store data in that table. And since we are using many tables to store data, sometimes when we need a related information about those data, we need to perform complex joins. We need to write complex joins on those tables to get the required result. And in RDBMS, joins are very expensive. Now let's have a look on the MongoDB. MongoDB will also have the database server, same as RDBMS. On the database servers, we'll be having our databases running. But here, instead of tables, we will be having collections. So in RDBMS, we will be having tables, but in MongoDB, we will be having collections instead of tables, and instead of rows, we will be having documents. So instead of tables, we will have collections, and instead of rows in MongoDB, we will be having documents. And since in MongoDB we are using collections, we do not need any predefined schema. We don't decide what kind of data our collection is going to have. On the go, we will be storing data in the collections, so we don't decide what kind of data is going to be in the collections. So MongoDB supports dynamic schema, and since we are using documents to store data, and sometimes we store data as a embedded documents, as a arrays, so we will be keeping data together in MongoDB in form of documents, and that's the reason when we need some information about data, we will be quickly getting that without writing any joins. So in MongoDB we need not to write any complex joins, and that's the reason MongoDB is very quick and fast compared to relational database management system. One more difference between RDBMS and MongoDB is relational database management system can store only structured data, and they can store data up to some limit, but MongoDB can store structured data, MongoDB can store unstructured data, MongoDB can store semi-structured data, and MongoDB can store huge amount of data. So there is no problem with the size of data. MongoDB can store any number of data. So these are the basic differences between the RDBMS and MongoDB.